Experiment 5, Enzymatic Resolution of DL-Alanine and Valine. To your 125 milliliter Erlenmeyer flask equipped with a stir bar, you're going to add 44 milliliters of DI water, followed by 6 ml of your 6 molar sodium hydroxide solution. Add your assigned alanine or valine to the flask and stir until clear. This can take up to 20 minutes. Obtain 7.4 milliliters of benzyl chloride using your graduated cylinder and immediately add this to your reaction flask. Then allow the mixture to stir for 5 minutes to make a cloudy mixture. Now add 6 milliliters of sodium hydroxide solution to the reaction flask. You can use the same grad cylinder as used before. Add a cork stopper, which you'll find in the drawer below the filter paper. Now check the reaction flask for heat. If the flask is too hot, you can use an ice bath to cool the flask. Stir for 20 minutes and then check the pH by using a glass stir rod that you've dipped into the solution and then tapped onto pH paper. Check that the solution is acidic. Then add 12 milliliters of 6 molar sodium hydroxide to your solution slowly portion-wise with shaking in between. A clear yellow solution with no oil droplets is your signal that the reaction is complete. This can take up to 15 minutes. Then you'll check that the solution is basic before moving on. Use the balance to weigh out 30 grams of ice into a 400 milliliter beaker. Slowly add 30 milliliters of HCl onto the ice. Pour the reaction mixture over the ice water in your beaker slowly. This will produce a white marshmallow-like solid. Now you'll let it stir on your stir plate for about 10 minutes. During this time, you should set up your vacuum filtration apparatus. Remove the stir bar from the beaker and then pour the solution into your Buchner funnel, which is under vacuum. Now use your spatula to scrape the solid away from the beaker onto your filter paper. The washes today will be done by adding the cold solvent to your filter paper with the vacuum removed. So to start, you're going to add cold water to your beaker, swirling it around so that you can try to transfer as much product as possible to your Buchner funnel. Then you'll add the remainder of your 5 ml of cold water to your filter paper, rinsing your solid. Return the vacuum line to the Buchner funnel and allow the water to pull through. You will repeat this cold water wash twice in total. Again, you're going to remove the vacuum line and you're going to rinse with about 6 ml of cold ether. Again, replace the vacuum tubing onto the setup. You'll repeat the ether washes until you've reached 3 in total. After your final wash, you'll pull under vacuum for at least 15 minutes so that your solid is dry. This white product is your benzyl amino acid product, which you will set aside for further analysis. You'll now prepare a solution of RS benzyl amino acid for your enzymatic resolution. To a 250 milliliter Erlenmeyer flask, you're going to add 150 ml of your citric acid sodium citrate buffer. Then you're going to add 0.02 moles of your benzyl amino acid product to this buffer solution. Stir this mixture and heat with a hot water bath until complete dissolution of this solid occurs. Feel free to use your spatula to break up any clumps to aid in this process. It is extremely important that you let the solution cool completely to room temperature. You'll then add 1 gram of hypane to your solution. If the solution is not cool enough, you'll denature your enzyme. This will cause further reaction to fail. Add 0.7 grams of R-cysteine hydrochloride hydrate to a reaction flask and stir. Once this is dissolved, then you're going to add 5 ml of aniline to your reaction mixture and again stir until combined. Once combined, you're going to add the remaining 50 milliliters of citrate buffer to the reaction flask and stir well. You will then stopper the flask using a cork stopper and leave it in the drawer over the break. Over the 2-week break, you should have produced solid in the bottom of your Erlenmeyer flask. Now set up a vacuum filtration system and add filter paper. Dampen the filter paper using water before filtering the solid from your reaction flask. Be sure to swirl your solution as you're pouring. Now you'll perform a series of washes using cold solvents. The first wash will be with 15 milliliters of cold water, followed by 2 washes using 1 molar sodium hydroxide. Then you'll end with 2 washes of 10 ml of cold water. After the final wash, we will continue to pull a vacuum so that we can dry our solid. We're going to aid in this by adding 2 pieces of filter paper and patting the solid to remove water. Then we are going to continue to pull air for 15 additional minutes so that we completely dry the annulid product. Now you'll weigh out 20 milligrams of your annulid product. You'll add this to a small vial which you have received from your TA. You'll dissolve this solid using 2 ml of chloroform. You'll do this by using a small syringe. In this case, I'm showing a 1 milliliter syringe. Cap the vial and shake well so that you dissolve the aniline completely. Take the solution with you downstairs to the polarimeter so that we can obtain the optical activity values. Make sure to input the correct values into the instrument. This is a polarimeter cell. It has a clear tube in the center in which you can shine light through. Using a syringe, you'll inject the solution that you just prepared. Check that there are no air bubbles in your cell by looking down the center tube. Now load the cell into the instrument so that you can measure the optical activity values. Press start so that the instrument will measure the optical activity. Once the instrument has completed its measurements, you'll be able to obtain the optical activity and specific rotation. Record these values in your notebook. They must be included in your lab reports.